Hey and welcome! Today we will solve merge to sorted linked list interview question, which mostly asked by Amazon. So let's dive in. First example here. This one comes with visuals, but basically what it asks for is that they give us two sorted linked lists and want us to give them back a new one, again in sorted order, but merge both of them together. And as you can see, the output contains both nodes from given linked list. Second example. Nothing in list 1, nothing in list 2, we're definitely going to return nothing. And finally, last example, again, merging these two lists will end up in an output like that. Let's think about how we're supposed to solve this problem. The idea for solving this problem is super simple. We need to iterate through both linked lists at the same time and compare values in each iteration. Based on that, we need to start to build up nodes for new linked lists that questions asks for. But we need to be aware that we are taking care of all demands that we already have, like how we might manage to iterate through two linked lists simultaneously, plus or newly built linked list on top of it. I mean, look at this process here. We need to add new nodes to it as well as moving forward iteration wise. And all of them has to happen at the same time. This is our challenge here, and this problem means to teach this exact technique for us. So the code for it is going to be simple when we understand this iteration challenge. Here is a basic loop for iterating through one linked list when we care about not mutating the linked list itself. We use a temporary current variable to hold the reference of head node and check, as long as that reference is not falsy, do whatever we want with that node. And finally, use that variable to move forward in the linked list itself. This is the original way of iterating over a linked list, and you will use this for most of linked list questions, to be honest. When we don't care about mutating linked lists, we can directly check for node, override it, and move forward in the linked list. In case of two linked lists, all we need to do is check if both nodes from both linked lists are trucy. Mutating the linked list is going to be our way to go in this problem, because all we need to care is return the new linked list as an outcome. But this condition brings us into our edge case. If we start to go through our iteration one by one and build the new linked list as we go through, at the end, the time just after we compared the last two nodes, we will be at the end of our first linked list. But the thing is, we will never get back inside of while loop again, because this condition here will never going to be true again, right? First linked list is now pointing to null, but still, there is more node left from second linked list that hasn't been taken care of. And in fact, there could be more nodes here. If we're supposed to merge, we better to do it for all nodes, right? The solution for this is simple again. Let's jump into the code and show you what we need to do for it. First thing to do is we need to start our result linked list from somewhere. So we will create an empty node. Next step is iteration part. So we will have a temp variable that holds a reference to head of our result linked list, and meanwhile use head nodes of given linked list to do the iteration. Before we move on to the comparison part, we need to consider moving forward in result linked list, and we should do the basic linked list iteration using our temp variable. Now it's time for comparison. If value of node in first linked list is less than other, we will make temp variable point to that and move forward in first linked list. Otherwise, we will do the same for second linked list. So here's the point that we need to take care of that one last node, or probably many nodes, from other linked lists. All we need to do is check for either of nodes being trucy, because if any of those nodes, L1 or L2, at the end, after we exit the while loop, is still trucy, it means that it contains value, and we are not finished with the rest of that linked list yet. So we are going to assign the next value of current temp node to either L1 or L2, whichever was trucy. Finally, since we started our result node with an empty node value, we will return its next to make sure that returned linked list does not start from null. It starts from a value. Now if I run this, test cases are passing, and if I submit, everything seems to be fine. Let's jump into the slides for time and space complexity analysis. For time complexity, we will have O of n plus m, where n is the node's length in first linked list and m is the same for second. For space complexity, it will be O of 1 because we did not pollute memory. We just arranged nodes from both linked lists to point to each other in a sorted way. So that was it for this video. Thanks for watching, and please leave a like, comment, and subscribe to the channel. I will put the link for linked list playlist in the description to check it out. And finally, hope you enjoyed this video and stay tuned for the next one.